using properties of determinants, show that the determinant 1a square, 1b b square, 1c c square equal to a minus b, b minus c, c minus a. So consider the determinant. The elements of the first column are 1, 1, 1. That of second are a, b, c, and third are a square, b square, c square. Look at the determinant carefully. The elements of column 1 are 1, 1, 1. So it is very easy to evaluate such kind of question where either in column or all the elements of a row are 1, 1, 1. How it is simple? Because here, when the elements of the column are 1, 1, 1, then we will operate row wise. And if the elements in the row are 1, 1, 1, then you apply column wise. So now, just see what will happen if you replace R2 by R2 minus R1 and R3 by R3 minus R1. Let me tell you here that when we are dealing with rows and subtracting or adding the elements of the corresponding rows and columns, remember, in a step, one row has to be kept constant with which we are operating. Like here, we are saying R2 minus R1, so it cannot be side by side R1 minus R3. So it has to be R2 minus R1, R3 minus R1. We are maintaining R1 as same. And what will happen now? The value of determinant will be, you see R1 we are keeping same. I repeat. And now R2 minus R1 gives you 0, b minus a, b square minus a square. And R3 minus R1 makes it 0, c minus a, c square minus a square. So immediately we get 0, 0, 2 zeros in column 1, which is very useful because when you will expand, we will get a single element. And now look at the right hand side carefully. You need to prove it a minus b, b minus c, c minus a. Do you find that in column 2 b minus a is common? Because after all, b square minus a square can be factorized b minus a, b plus a, b minus a is common. Similarly, from c square minus a square, we may take c minus a common. So here you instruct that take b minus a common from R2 and c minus a common from R3. So you get b minus a times b minus a and into c minus a. Again, you know, the row 1 remains the same. 1a square still same. Taking common means divide. You get 0, 1. B square minus a square has two vectors, b minus a, b plus a. So if b minus a is common, you will left with b plus a here. Similarly, from the third row, 0, c minus a common leaves you 1. And c square minus a square have two vectors, c minus a, c plus a. C minus a you have taken common, so you left with c plus a. And now, you see, again, look at R2 and R3 carefully. If you take C here, the R2 minus R3, what will happen? So change R2 to R2 minus R3. Already you have outside, keeping b minus a and c minus a as such, and as I told you, we have applied, applying R2 minus R3, keeping 1a square elements of group 1 same. R2 minus R3 gives you 0, 0, and b plus a. See, you have b plus a and minus c plus a means minus c minus a. So a will cancel and you will left with b minus c, the third element of second row, and of course keeping 0, 1 and c plus a the same. And now at this stage we can expand with C1. Already two zeros are there. So you have b minus a C minus A, and when you expand you get 1 times, delete the row and column through 1, so you get 0 into C plus A is 0, and minus 1 times B minus C, so of course you get minus B plus C. And now because we need A minus B, B minus C, C minus A, and you have B minus A, take a negative sign common to make it A minus B, C minus A as such, and from inside the bracket you have negative times B minus C. So this negative and negative cancels, and we get the required result after rearrangement, A minus B, B minus C, C minus A, and that is your required right hand side the value of the determinant. In question 1-8, first part, this 1, 1, 1 was there in the first column, so we applied R2 minus R1 and R3 minus R1. Now this time, in this question, what is your left hand side? Determinant 1, 1, 1, A, B, C in the second row, and A cube, B cube, C cube in the third row. So 1, 1, 1 is there in the row. So by applying C2 minus C1 and C3 minus C1, you will get 2 zeros, and of course we will take C1 constant. So keeping C1 constant, you apply C2 to be replaced by C2 minus C1 and C3 to be replaced by C3 minus C1. So your determinant will become, the column 1 will remain the same, 1A cube will remain the same. Applying C2 minus C1 you get 0, B minus A, and B cube minus A cube. And taking C3 minus C1 you get 0, C minus A, C cube minus A cube. Now obviously we can take B minus A common from C2, B minus A common from C2, and C minus A common from C3. How can you take common? What are the factors of A cube minus B cube? The factors of A cube minus B cube are A minus B, A square plus B square minus AB. Using this formula, when you take B minus A and C minus A common, see how it works. Taking the first column, the first row, first column, that is 1A, A cube remains the same. You are taking B minus A common from column 2, so you get 0. From B minus A you get 1. Now what are the factors of B cube minus A cube? B minus A you have taken common, and the other factor left will be B square plus A square plus AB or BA, whatever you do. Similarly, C3 minus C1 will make it 0 and 1, because you are taking C minus A common from C3. So you get 0, 1, and what are the factors of C cube minus A cube? The factors of C cube minus A cube will be C minus A, you have taken common, and the other factor you will left with is C square plus A square plus CA. And now if you further take take C2, you change from C2 minus C3. That will give you an extra 0, as well as this term A square will cancel. So applying C2 minus C3. Yet B minus A and C minus A as such, and C2 minus C3. So C1, 1A cube as such. Even in C2 you are subtracting, so it is 0 minus 0, 0, and 1 minus 1. This 1 minus 1, 0. And now see, this A cube will cancel, so you will left with B square plus AB minus C square minus CA or AC, whatever you call. And the third column, that is 0, 1, and C square plus A square plus AC will remain same. Determinant. And now we can expand with R1 because it has got 2 zeros. Expand along R1. you know you already have two factors out, that is b minus a, c minus a, but instead b minus a you need a minus b, so take a negative sign common from b minus a, so minus times a minus b, c minus a, and now expanding with row 1. Expanding with row 1, you get 1 times, delete the row and column, so 0 times c square plus ac will be 0, so you get minus 1 time b square minus c square plus ba minus ca. And this 1 and 2 has no meaning, will remain the same, and this minus and minus will become plus. So you get a minus b, c minus a, and now this expression c could further be factorized. What are the factors of b square minus c square? B minus c and b plus c. And out of these two factors, if you take a common, so you get b minus c. So now from this you take b minus c common, a minus b, c minus a. Taking b minus c common, you left with b plus c plus a, which is the required result. Let me write in proper order: a minus b, b minus c, c minus a, and this b plus c plus a may be written in a better form: a plus b plus c, and that is the required right hand side.